So this presentation, I will go into the open network or open programmable network architecture vision. It's something we've been working on at KPN, not so much explaining the reference models, the reference designs of ONF, but the things we want to do with our open networking architecture. Before going into the architecture vision, we thought of a bit of a background in the things we've been doing in the infrastructure over the past years. Based on the KPN strategy. So KPN strategy for a number of years has been to simplify, grow and innovate, and this is something we see in the entire company throughout all layers. So we're within the network, within our IT, and within the organization. So what we've done over the past years with the infrastructure is we simplified the infrastructure in terms that we consolidated a lot of different networks into a single infrastructure, and this is near to completion. To support growth, we had to increase bandwidth, and we will keep on increasing bandwidth. We are also decentralizing our content and functions more towards the edge of the network. So where we first had the centralized architecture with centralized data centers and services, and we also had our centralized IP. We now have moved these functions to about 160 locations or 200 locations into the network. Again, to facilitate growth in the network. And the last thing we've been working on, and we're on the innovative part, the virtualization of the network functions and service functions. Has also been discussed in earlier versions of this conference. We've started to virtualize some of the application and network functions. So moving away from appliances and dedicated network functions and more on x86 infrastructure. So we're trying to move from a legacy network with dedicated appliances to a more generic hardware-based network and infrastructure with virtualized functions. Now the next step, this will be actually more or less going more into more detail or evolving the view on how this generic infrastructure should look like. So the future network architecture we've been thinking of, so on the one hand, it should satisfy the ambitions we have as a company and the drivers from our business and ops. And on the other hand, we have the technology making things possible, right? So many of the drivers or the ambitions you will probably recognize. So typically for an operator, traffic grows, revenues don't grow at the same pace, so we need a lower cost at the same time. So this is a balance we need to strike. For us, it's also important to improve our continuity. The network is becoming like the water from the tap. It needs to be there always. So having failures, we need to improve the continuity and the availability of the network. And ideally, we would like to have an infrastructure where we could change infrastructure or change the network without having impact on customers or without having impact on services. So to do this, we came up with an architecture vision which is based on, let's say, 4 pillars or key features, if you will. It's software defined, it's distributed, it's disaggregate, and last but not least, it's open. I will go into each of these briefly. So software defined. Well, as an extension to the virtualization, it obviously means that we're going from physical network functions to virtualized network functions. So that's a direction we will continue. Another, if not a very important aspect of this of a software-defined architecture, it means a fully automated architecture. So not only automated in the sense that we can automatically provision the network, but also that the automation layer will take information from the network, events through, and then based on models and artificial intelligence, which we had some talks about as well, define actions that will directly feed back into network to change or do otherwise things to the network. And last but not least, software defined in our view means we need to have a programmable infrastructure. And the programmable infrastructure, mainly also the programmable network layer, is a key component of the architecture. The programmable network layer, we go into that a bit more detail in later slides, but as we virtualize network functions, we see we don't want to run all functions into the compute layer. So we want to be able to offload some of the virtual network functions into the network layer again. So this is why we think the programmable network layer is needed. So then it needs to be distributed. So we're going for a more centralized approach, where we're centralized also in terms of equipment. So we have large boxes. We want to go for a more distributed approach, where we have the leaf-spine topology, which was mentioned already a few times earlier, which allows us to easier scale, but also to have an easier way to change equipment without having direct impact on services and customer experience. Furthermore, we should be able to distribute functions and distribute services to the edge. We already started this. The architecture should be open to this. We started this for high volume services like the TV content and video content that's already at the edge. 5G is possibly demanding having to have functions at the edge as well for delay or even for, and also some of the control we want to place more towards the edge and less centrally. So in this sense, it needs to be distributed. And then this is something that's been ongoing for a while, but is to disaggregate the architecture. So the architecture should be disaggregated on various levels. So we want to decouple hardware from software, so be able to run different types of, or any software on any hardware ideally, but the important thing is to have the decoupling. So the decoupling between the hardware and software. We want to be able to select hardware independent from software and select software independent from hardware. Also important thing, and that has to do with the programmable network layer, is to separate the forwarding and control. So where some of the heavy functions, traffic bearing functions, although we want to have some automation and software defined aspects in there, still the forwarding part of this we want to keep as much as possible in the network, at least for the large traffic flows. So this and the control then could be in the compute layers. And last but not least, the hardware and software itself should be disaggregated or modular, if you will. So we want to be able to change components or introduce new components without having to redo the entire stack that we have. Obviously, this disaggregation can only work in a proper way if we got an open interfaces everywhere. So the architecture should be open. Open in all layers to have interfaces which allow us to interchange components in the architecture without having the impact on the overall stack that's making up the architecture. So we'd like to have open interfaces from the hardware level onwards, and then within the control and upwards to the control. But also open interfaces more on the data plane itself. So right now, in particular, the optical interfaces are more or less proprietary. So if we could have open interfaces and at this level, at the transport level as well, this would also something would really help to have interop and be able to exchange components and reduce the lock-in. It also should be open in terms of open source. So we are actively looking into and have also joined the Open Networking Foundation and Open Compute to have a more open source approach to networking, also to speed up developments and leverage the community effort that's being done up there. You already see a number of the logos that has been shown before in the previous presentations as well. So things we're looking at is, for instance, Stratum, ONUS, and Chord, as well as the P4 as a programming language to define our programmable network layer. Building blocks we see as some of the key components in the architecture are Chord and UPAN. So while Chord brings a lot of flexibility and also a lot of the aspects that I've pointed out earlier, the things that at least initially was missing is that all the traffic, all the functions like a BNG would be inside the compute layer. We would like to keep this into the network layer, because almost all of our traffic goes through that function, and it's rather inefficient to pull this all the way up to the compute layer. So this is where we see UPAN coming into play, allow us to program BNG type of functions in programmable hardware, and also not only BNG, but be able to introduce new functions and make combinations of functions that are currently not possible, at least not for an operator like us, simply because vendors have made different decisions and how to implement these functions. So for now, it's all generic building blocks. Some specific use cases we have. We have a number of use cases for the programmable network architecture. I'll explain. I will cover two of them right now. So this is a very almost everything encompassing use case, which you could see as more or less the central office or court. It's not really a central office in terms of how you would define this, but this is one of the about 160 locations or areas we have. This is where we have our BNG, and currently we have a traditional BNG. It also performs a layer 3 PE function. We have content up there in terms of CDN. And in the new architecture, we would see it something like this. So we define a programmable disaggregate central office with the basic architecture as a leaf spine topology, with the spines being service agnostic and the leaves doing all the service functions. Leaves are sometimes inside this central office, so inside the building, but we see also leaves part of the same structure outside of the building. So it's more. So these are remote in terms of the controller. So there's a controller that's controlling all these leaves, for instance, ONOS. And then the leaves form the service functions. So one of the services I mentioned earlier already is the BNG function. We want to put in at least the BNG user plane into the switches. Other ones could be also have to have the mobile user plane into the switches, so the combination of the BNG and the packet gateway into the same box. This for us could be important. Mobile traffic is growing. We don't know exactly how large it will grow and how fast it will grow. But if we have the function in the same equipment, well, if we use the switches from fixed to mobile access, the traffic, we don't have to build the capacity twice, right? So if it's only a small portion of the traffic, it's not that bad to build capacity twice, but if it becomes really big, having a more efficient way to handle this traffic is starting to become important. Another feature is that we want to multi-home our access, so the fixed access as well as the mobile access to the network equipment to improve the resiliency. So if a leaf fails or there's a failure, we can switch over to another leaf and carry the traffic in there. And we think with a controller-based architecture, this hopefully will become more easy for us to do. To simplify our transport, well, we currently run MPLS. It's already pretty basic, pretty simplified. But to reduce even further the number of protocols, and at the same time introduce programmability of the forwarding plane in a different way, but to allow service chaining, for instance. Segment routing v6, so Andrea, here you have your segment routing requirement. This would be a way to do this, to have a single transport protocol in there. So this is something that's maybe a bit further ahead. There's a number of components in there. But the thing here, the programmable data plane would bring to us is to be able to expand the functions beyond what we can do today. So today we can buy a BNG, we can also buy a packet gateway, but we cannot get something that does both at the same time, even though if you look under the hood, the hardware is nearly the same. Also, the multi-homing aspects of the access is something we think with the controller-based architecture will become more easy. Plus, we can do some specific functions if we need to. Like the specific functions in this case will be most likely in terms of network telemetry, which we could do some specific things in. Another use case is something very different. It's also a bit more simple, but it requires more specific functions. It's use case for monitoring of traffic. So here we have a case where we do intercept of traffic and monitoring of traffic by copying all our traffic or large parts of our traffic to a switching structure. And within these switches, we select the interesting traffic for applications that need it. So from the application point of view, we define filters, and then we send off the traffic to these applications. Now, if we send large amounts of traffic, this will become expensive very quickly. So we need to have a cheap, low-cost solution, hardware, but also one that's very flexible. And what we've seen is that with, for instance, it's fairly easy with a P4 programmable switch to come up with a low-cost solution that actually can do filtering on a level we cannot do with more traditional solutions today. At the speed of development, we cannot achieve as well. So this is another use case for programmable switching, maybe not as elaborate as the previous one, but also something we're looking into right now. So where are we going further with this? So right now we're refining the architecture vision, trying to get from the vision into more development of POCs, etc. Key elements that we think we keep. So it's software-defined, distributed, disaggregate, and open. So this is something we're looking into. The programmable data plane is a very important part. So we joined ONF and the OCP to drive further these things. We see them as key building blocks, maybe not right in the way as they are now, but maybe in a slightly different form. And we're looking forward to work with the community to further drive developments and based on the use cases we have and share this. Yeah. So for this, I'll close. This is the end of my presentation. For any questions or remarks, there's a few more minutes.
How much of your network is this way now versus the? I assume you're still early.
Yeah. Well, we are way before deployment, so we're now building a lab. So part of the network that's there now, it's 0%. But we are looking into what steps we can make in the next 2 years to get closer to this. Because so this is kind of set to be the target for 2025 as some kind of a date, but to get there we need to make steps already in the coming years. Right, Andrea?
Thanks.